And so ini 6 benda yang everywhere ada when it comes to offshore construction and installation. Hopefully you guys still on okay? If you're okay, just type in the chat supaya I tahu you tak tidur. I know dah petang hari Ahad, time ni nak tengok wayang. So kita try to keep it active lah. Sebab I tak nampak you. I nampak screen je. Jadi if you're okay, tekan give a thumbs up, cakap okay in the chat so kita boleh move forward slowly. Okay, so all of this, initially I plan nak buat macam, thank you Asha. So I plan nak buat macam, you guys pilih nak yang mana, and then I tekan dia zoom in kat situ, and then contohnya you nak subsidi dulu kan, I tekan situ dia zoom in, kita cakap pasal subsidi dulu. Malangnya aku tak ada masa kena beli guni kahwin, tak sempat nak edit tu, so kita ikut time jacket, flex lay, ROV rigid floater and subsidi Okay, boleh minta maaf. Minta maaf Okay, so first, just a very quick summary. A jacket is not jacket yang you pakai waktu sejuk tu ataupun time hujan sekarang. Is a jacket is bila platform yang ada kaki, bila shallow water. Okay? Jacket ni is dia punya kaki yang fix all the way to the seabed. Dan jacket ni besar, sangat-sangat besar. Some jackets boleh setinggi macam satu apartment yang 30 tingkat dekat KL, contoh. Sebab kenapa dia kena besar? Satu, sebab if water depth tu sangat dalam, dia kena sangat panjang. And if dia sangat panjang, dia kena sangat lebar. Sebab apa dia sangat lebar? Kalau dia kurus, dia jatuh lah. Jadi dia kena bentuk daripada besar base dia, makin kecil untuk support top side dia. Okay. Flex lay is apa I buat mostly. Actually about 80% of the time, I buat flex lay. I pun yang lesen buat benda ni. Is kita install pipe yang boleh bengkok. It's actually quite interesting. Dan sebab pipe tu dia bukan section by section. Kita tak well. Kita buat manufacture kat kilang, sudah boleh dibengkok. Macam hose you tembak air siram pokok petang-petang. ROV stands for Remote Operated Vehicle. And these are robots termata dan tangan kita dalam air. Kita akan go into deeper. Rigid pipe lay also boleh bengkok actually. Tapi dia punya bengkok, dia punya bend is not as extreme, as intense as flexibles. Tapi rigid yang ini, dia nampak yang line hitam tu, that is actually a rigid pipe, which is quite amazing jugalah. Sebab sometimes rigid pipes ni menjadi besar. 10 inch, kita guna inci lah. Kita guna American Matrix. Kita guna Imperial. 10 inch, 12 inch, maybe 8 inch, they can go into deeper. Floaters is the structure, or some people call it rigs or floaters. Ni sama je macam platform yang nampak tu, tapi dia tak ada kaki. Dia timbul. Yes, you bayangkan SMK you, sekolah you dulu, the whole sekolah bertimbul atas air. Jadi you boleh pergi tingkat 4, tingkat 3, tingkat 2, tingkat 1. Kalau ada basement parking, sekolah apa ada basement parking, you boleh pergi itu juga. And all of this will be floating. And you tak akan rasa a single wave hitting you. Sebab structure yang sangat besar, sangat berat. Sometimes it can be thousands of tons. That is 1,000,000 kilogram. And you tak akan rasa anything. Unless if the water sangat extreme lah. Kalau let's say in a storm situation where ombak dah setinggi 20 tingkat dan you kena tahan je lah. Dia takkan putus, jangan risau. Setakat ni, there has been rarely any case where a floater tenggelam out of nowhere. Kecuali kalau something meletup, seperti Deepwater Horizon. The last is subsea. Ni benda yang nobody nampak, dan I rasa benda ni yang paling orang tak tahu, especially kalau orang yang nak masuk oil and gas, they don't know anything about subsea sebab dia orang tak nampak. Usually orang kata aku nak kerja offshore, aku nak kerja offshore. Dia fikir atas kapal ataupun atas platform dengan rigs. But actually banyak benda yang happen yang dia orang tak nampak langsung is underwater. And I think today ada pasal drilling, I cakap pasal wellheads and drilling semua tu. Which kita connect all of these wellheads with Christmas trees, which Christmas trees ni bukan kita celebrate December, tapi untuk control flow, untuk keluar out of that reservoir, yang kita commingle ataupun kita connect everything dan kita bawa pergi ke tempat yang nak kerja, itulah atas kapal ataupun atas platform. Okay, so kita pergi straight to jacket. I zoom in, sorry for the bad resolution. So jacket installation, benda ni sangat besar, benda ni sangat berat, dan benda ni kena tenggelam. Tapi dia kena tenggelam dengan cara kita nak dia tenggelam. Kalau dia tenggelam cara kita tak nak dia tenggelam, kita just buang ni kat tengah-tengah laut. So it's very very important kita control dia punya sinking. Now, how do we bring benda besar ni ke tengah laut? Usually banyak I dapat soalan, especially my social media ke online ke atau even bagi talk, orang tanya macam mana kita bina benda-benda ke tengah-tengah laut tu. Jawapan yang I selalu bagi, kita hirup semua air kat laut tu, and kita bina kat situ, kita letak balik air. But no. All we do is kita bina benda tu kat darat dulu, and then kita bawa ke laut. Okay. Sometimes bila bina jambatan, which tak ada kaitan dengan offshore, bina jambatan yang kaki dia kita actually buat, I tak ingat apa nama dia, entrapment tu. Basically kita keluarkan air, kita buat satu tempat where tak ada air, kita boleh bina kat situ, and kita masukkan dia, kita floodkan balik. Tapi offshore kita tak boleh, sebab laut ada banyak air. So kita kena bina kat darat dulu, then kita bring di laut, and then kita install kat situ. Okay, so we don't actually do any offshore construction per se. Kita construct di darat, and then kita install di laut. Sama lah macam kalau you nak install aircon kat rumah. Takkan orang tu nak bawa all the component pergi rumah you, pasang kat situ, lepas tampal kat dinding. Dia dah buat kat kilang, and then dia akan bawa rumah you tampal ke dinding. Okay? 1 minit jap. Okay, so untuk jacket installation, kita ada 3 benda kita kena fokus on. Is towing, upending, and piling. So towing, how do we bring this large, massive structure into the middle of the ocean to where our site is? Number 2, upending, is how do we make this from a horizontal position, tengah baring, all the way into an upending position, yang menegak. Sebab kalau kita turunkan dia dengan orientation macam ni sekarang, kepala dia tak akan keluar. Dia akan semua benda lamai. So kita kena tegakkan dia. And last but not least, piling. Kita macam piling rumah, kita kena make sure dia tak gerak bila dia dasar laut. So sometimes in water, the current is very, very high, and also the seabed can be very soft. Jadi kita tak nak dia gerak. Tak nak dia nanti diletak kat sini, next time we datang balik dengan topside, dah hilang. Dah pergi kat sana, dah pergi ke simpang pulai. We don't want that. Okay. So, towing. Kita letak benda ni atas kapal. Yes, it sounds crazy. But oftentimes kita letak benda ni on what we call as barges. Barges ni is just basically a floating platform. Platform's the wrong word. Macam satu benda yang boleh timbul. You pernah tengok Titanic tak? Where Rose kan dia baring atas pintu tu kan, and then Jack duduk tepi, dia tak boleh naik padahal muat dia 2 orang. Kan Rose baring atas pintu dan pintu tu terapung. So you imagine pintu tu sebesar-besar parking lot, or even bigger than parking lot, and then that's what we call a barge. It's just a flat floating structure per se. Dan dia punya density sangat-sangat rendah, so we can put a bunch of stuff atas dia walaupun 1 million ton, but it can still float. That's impressive again. So kita letak structure ni atas ni, dan of course kita kena well structure ni to the deck of the barge, sebab kita tak nak, basically pakaikan seatbelt lah, tak nak bila dia gerak benda tu terus jatuh. We don't want that. Jadi kita kena make sure dia secure, ataupun what we call as sea fastening onto the structure. Okay, and oftentimes barges, sebabkan dia just a big block yang high, yang very, very low density, kita tak ada apa-apa on it. Sometimes toilet pun tak ada atas tu. Jadi apa-apa crew kena keluar naik kapal lain, pergi toilet, patah balik. Tapi usually tak ada orang atas kapal, atas barge tu. Then oftentimes barges don't even have a propulsion system. Maksudnya dia tak ada propeller. Dia tak ada benda nak tolak dia. So kita kena guna tugboats untuk tarik dan untuk tolak. And this is just a very short, I cut, of course, again, I curi dari YouTube. Jangan betul siapa, between me and you, I see that. Is about animation, about how do we tow these jackets in the middle of the ocean. Is either kita kena tugboats, ataupun sometimes the installation vessel itself boleh tarik, but it's highly unlikely lah sebab kita tak nak damage any equipment. Usually kita guna tugboats untuk tarik. Tugboat ni besar, jadi kita ada very high torque, dia boleh pull. So kita bawa all this massive structure, bawa to site, and dekat site oftentimes akan ready satu lifting vessel, a heavy lift vessel. Now heavy lift vessel ni is actually sangat-sangat besar. Essentially it's just one giant crane kita timbulkan. And oftentimes bila nampak kapal ni sangat-sangat besar, kalau let's say you nak terbang, you fly over this port macam dekat Johor ke kat Kelang ke, you boleh nampak dari atas sebab crane ni sangat-sangat besar, sometimes boleh like 800 ton, 700.5 ton crane capacity, dan tiba-tiba sekeliling dia, atas dia ada boat. So we built the ship around the crane. Okay, it's very, very common practice. Sebab kenapa kita kena perlukan this heavy lift punya vessel is kita kena figure out some way untuk angkat this jacket lah. Sebab if not, macam mana kita nak angkatkan dia? Okay. So apa kita buat is kita bawa this barge with the jacket near this heavy lift vessel supaya dia ready untuk angkat, dan kita deploy dan install di laut. Kita push. Basically these tugboats are very, very cool lah. You boleh nampak sebab tugboats ni they are very cool. Dia boleh push, dia boleh pegang kapal, and dia boleh push closer to where they want it to be. Okay, and that's it. Right. Okay, so bila dah sampai dekat dengan heavy lift vessel ni, how do we lift, how do we upend, how do we launch? Contohnya, launch ni is separate sikit. So lifting ni macam ni kita angkatkan dia, kita guna heavy crane ni. Upending is how do we angkatkan dia, dan launching ni is something yang McDermott buat, tak silap. Is instead of dia guna crane untuk angkatkan structure ni di udara dan diturunkan balik di air, is dia lepaskan structure ni, basically dia buang structure ni di laut. Hopefully you can see. Hopefully okay lah, tak terputus elektrik. So structure ni, this jacket, dia launch, dia tenggelamkan part of the barge on the track, the jacket ni, then dia akan releasekan di laut. Now, it's very risky, sebab if your ballast system, if your structure tak timbul, dia terus tenggelam. And we don't want that. We don't want that, okay? Kalau dia tenggelam, kita probably akan tuduh intern mana yang buat ni. So, kita launchkan dia, dan animation ni is a bit different sebab dia terus boleh up and sendiri. So, I think this is quite shallow water. This is quite shallow water. So, sometimes bila kita dah launch, dia masih lagi dalam position yang baring macam ni, still in a horizontal position. And then, baru a heavy lift vessel akan datang dan tegakkan dia balik. Now, there's a lot of benefits actually untuk buat macam ni. It's because suction dalam air, siapa ingat Archimedes principle, sebabkan suction dalam air lebih ringan. It's ringan by 0.13 ratio. Jadi contoh kalau suction ni 1 ton contohnya, it's only 0.13 ton. Itu sangat ringan. So now, bila suction dalam air, then we can upend it. Contohnya macam gambar yang nampak di nombor 2 ni, that is upending in water. Dia actually, you require a smaller lift vessel. Just risky dia is that you actually need to invest dalam ballast tanking. Sebab kita nak benda ni tenggelam accidentally, dan kita kena also invest dalam ballast control. So it's all about a balancing act. Okay. And since video ni also ada include pasal how to lift the top side sekali. So ni structure ni, vessel ni akan dipulangkan ROV, and dia akan connectkan all of this piling. Dia basically this is a suction pump. Dia akan keluarkan air dalam kaki dia. Dia akan tenggelamkan sendiri structure ni. So I think structure ni is quite shallow water. So dia boleh buat benda-benda macam ni lah. Dia jadi suction pile tu, dia keluarkan air, create a very low pressure. Very low pressure, then dia akan push all the water inside. Okay. So how if the jacket tidak tenggelam the right way? Dan kita tak nak lah jadi macam tu actually. If dia tak tenggelam the right way, then all the engineer and design tu akan in huge trouble. Okay, so at least so kita memang design it to be controllable. We have to be very careful how we launch the jackets. And you can see from the right ni, this is how we actually install it in the top side. Bila jacket dah secure kat bawah tu, kita akan bawa another vessel with the top side. Top side ni yang benda yang nampak kat laut tu lah, yang benda macam pelantar-pelantar minyak tu. Dia akan bawa over the jacket, dia akan rendahkan, dan dia akan weld. That's it, simple as that. Something like this. And sometimes dia ada jack up lagi, dia akan push structure yang naik. But this is all too complex lah, which kita tak akan go into that. Alright, so another animation yang I curi online is jacket lifting. Ni dia akan angkat by the heavy lift vessel tadi, and then dia akan turunkan dulu di dalam air sebelum ditegakkan, because jacket ni besar. Okay, and since kita ada some form of ballasting kat sini, dia boleh timbul sendiri. Okay. And from here, baru kita connect kat kepala dia untuk kita upend-kan. So you can see macam kapal yang ada atas ni, nampak tak crane dia besar mana? Tiba-tiba ada kapal kat depan. This is how it is. So kita upend-kan dia, tegakkan dia, supaya kita boleh orient the right way that we want it to. Jacket upending, that's what we call it. That's it. Alright, so next is piling. This is fairly simple. Macam yang kita nampak tadi, the suction pile. But sometimes, because jackets are massive structures, especially for deep water, sometimes suction piles are not enough. Suction piles maksudnya untuk dia secure ke dasar laut, kita guna pump je. Kita make a low pressure cabin, kita cylinder tu kita lowkan pressure supaya dia boleh tenggelam sendiri. Gunakan pressure saja dan weight of the structure itself. Tapi sometimes because benda tu besar sangat dan suction pile tak cukup, sebab you kena ingat, if the structure is like 1 million kilogram, the suction pile has to be sangat-sangat dalam. And because it's sangat-sangat dalam, you need a much stronger pump untuk depressurize that center. Jadi sometimes dia tak feasible. So what we do is kita buat piling. Macam piling rumah tu, dalam all these jackets, dia ada slots where you boleh masukkan these piles. And bila you sucuk pile ni kat dalam, you akan ada this jackhammer lah, basically. Dia boleh push sampailah dia fix to the seabed. Dan dia ada ukuran tu supaya kita boleh tahu how deep are we actually hammering it down. Okay, that's pretty much it. So that's about jacket installation. Okay, steady baru setengah jam.